Sanitary metal pipe clamp and a temperature sensor is a non-invasive temperature measuring sensor. Without disturbing the fluid flow inside a pipe, the temperature can be measured with the lowest response time of 5 seconds and with high accuracy of plus or minus 0.5 degrees Celsius. Installing the sensor on the pipe requires less than a minute. There is no need to weld the sensors to the pipe for the measurement. Only we need to clamp the sensor on the pipe. We can mount a sensor where we want to measure the temperature without any restrictions. Only we need to care about the maximum operating temperature. And another cool thing is it's IP65 rated. To start the measurement, we have to install the sync software on the computer from the Omega website. The software is user-friendly and doesn't require hours to know all the features. Once the installation is completed, we just need to attach the M12 connector to the sensor and USB to the computer. The sync software automatically detects the sensor connections. You can see on the left top corner, my device ID will be displayed. Here, my sensor is a 2-inch sanitary sensor, and there is not much difference is there between 1-inch sensor except the clamping diameter. We can change the metal pipe diameter thickness of the pipe in the input setting. These settings affect the accuracy of the measurement, so be sure to know your metal pipe parameters. We can set the temperature alert alarm notification based on our preference. These features can be selected by clicking on the bell icon. N number of temperature alerts can be created according to our requirements. Here I am going to create two temperature alert alarms, one for high temperature, another one for low temperature. In the capture data mode, output of the temperature measured is displayed. When the temperature reaches the threshold levels, what we have set for the temperature alert alarm in the configuration mode, the temperature will start notifying the temperature in red background. The sensor data can be exported to the CSV file in this mode only. You can see the temperature variations in the graph. The temperature is high. I have set the high temperature value as 27 degree greater than 27 degree. So it starts showing the temperature value in the red mark. This is the alert for high temperature. You can see that the output of the alarm is showing as a high. Next, I am going to decrease the temperature of the machines. You can see the temperature is cooling down now. I have set the temperature value for low temperature value for 16 degrees Celsius. Once it reaches the 16 degree, the low alert will be displayed on the red mark. To cool down the temperature, it takes a lot of time. So we are creating the simulation in a device by heating and cooling the main device. The devices can be seen in the first picture, introduction pictures. You can observe the low temperature warning. It reaches the 15.6 degrees Celsius. Now it's going down below that. Another cool thing about the unclamp sensor is it doesn't affect with the ambient temperature. So the output of the sensor doesn't affect by the ambient temperature. So we are increasing the temperature of the device. The temperature of the device is increasing. So it reaches 30 degree. So I have tested the maximum temperature range. So what they mentioned in the data sheet. So it gives the value exactly what's the temperature inside the pipe. You can observe the waveforms. So I'm going to attach the Excel sheet of the output in a below file. You can go through that. We're increasing and decreasing the temperature in order to simulate how it responds to for the variations in the temperature. Again, we decrease the temperature. So we can zoom in and zoom out the temperature values. Now I'm zooming the temperature, high temperature value. The highest temperature we reached is a 46, 40, again, above the 45 degrees Celsius. So we have reached the lowest temperature value of 14 degree. So we can zoom any temperature value and we can zoom out any temperature value. The sync software is very accurate and it's very user friendly and it doesn't require hours of time to know all the features. The output of the temperature measurement can be seen in a CSV file mode. The file stored in locally on the computer, we can see the data anytime. Since the sensor has the highest accuracy, output